Today's lesson is a review on solving problems with a technique called unit analysis. So take out this sheet of paper, this handout, if you have it. If not, take out a piece of paper and solve these problems with us. So you can pause the video, get your piece of paper or handout out, and then start it again when you're ready. So here's our first problem. It says, calculate the number of liters in 9.6 gallons. So how do I solve this using unit analysis? Well, there are 6 steps that we're going to follow to solve any problem with unit analysis. So let's go through them step by step. Step 1 is, what are you trying to find? What are the units in the answer? You should always know where you're going so you know when you get there. That's kind of my philosophy. So let's look at this problem again. What are we trying to find? Well, we're trying to find the number of liters in 9.6 gallons. So I'm going to put an equal sign and a liters so that I know where I'm going, and then I'll remember when I get there. So that's pretty easy, step 1. What about step 2? Step 2 says, what are you given? So not only do I want to know where I'm going, but I want to know where I'm starting. So what are you given in the problem? And then we're going to put it in fraction form. So the only thing that's given to me in this problem is 9.6 gallons. So I'm going to start way over here and write 9.6 gallons. And I'm going to make that a fraction. So you can make anything into a fraction if it's just a single number by putting it over the number 1. So that's a fraction. So I know where I'm going. I know where I'm started. Now I have to get there. So how do I get there? Well, the next step is you might need some more information. So is there any other information you personally know or you can look up that will be helpful? We're looking for things that are called equivalencies, things that are equal to each other, and we're going to use those in fraction form. So these problems are a little bit easier because it gives me a whole bunch of information. So I can use this at the top of the page. All this information is not always given to you. Sometimes you'll have to look it up, and sometimes you're just expected to know some information. Like eventually you need to know some of these equivalencies, like there's 100 centimeters equals 1 meter. So some of these you will be expected to know. But right now we're going to take it off the list. So what does this information tell me about gallons and liters? Well, here's some information I have. There are 3.78 liters, which are equal to 1 gallon. So that's something helpful that I can use. So I'm going to put a multiplication sign and then a fraction. And then we're going to go on to the next step. So the next step is already at step 4. We want to set up the problem so unwanted units cancel and you end up with the desired units. So what are unwanted units? And what are desired units? So the desired units are what you have in your answer, and the unwanted units are anything that you have that's not liters. So I want to get rid of everything else and get to liters. So the everything else here is only gallons. So I need to get rid of gallons and I need to get to liters. So I have this equivalency that I'm going to use. So to get rid of the gallons, if you remember math, if you have a fraction that you're multiplied by another fraction, if something's on the top of one and the bottom of another, they'll cancel out. So I have 3.78 liters equals 1 gallon. So what goes on the top and what goes on the bottom? Well, if I want to cancel gallons, the gallons has to go on the bottom and the liters have to go on the top. So gallons is going to cancel, and now I got rid of the unwanted units, and all I have left besides the numbers are my desired units. So I'm good. So finish step 4. Step 5 is simply to solve the problem. So let's go ahead and get out your calculator. And all I'm going to do is multiply 9.6 by 3.78. Now your calculator often gives you lots of numbers. So let's put down first the unrounded number, and I'm not going to put down the whole thing, but we get something like this, 36.288 liters. Okay? That's too many units, too many digits. I have to do significant figures also. So I go back and look. I have 1, 2 significant figures here, 1, 2, 3 significant figures here. So I can only have 2 significant figures in my answer. So I have to round this to 36. What do I do with this part? I can get rid of that because it's not more than half. So I end up with my final answer as 36 liters. Now, step 6, I often forget, but you should not. It's very helpful. And anytime you're solving a problem, you should always check your answer. And for unit analysis, you can check your answer by asking yourself the following questions. Do the units cancel? Okay, if not, you might have to flip something. Did you get the right units in the right place? If not, once again, you have to flip something or get a different fraction. And at the end, does the number make sense? So we should always use our logic when we're solving problems. So units did cancel, gallons canceled, I'm left with liters. Liters were in the top here, liters are in the top here. Remember, it's technically over 1, so I have the units and they're in the right place. And 36, does that seem like a reasonable number? Well, I started with almost 10 gallons, and there's a lot more liters than there are gallons in the equivalency, so I should end up with a bigger number than 9, and I do. So 36 liters does sound like a good answer. All right, so now I've done all 6 steps to solving problems, and that was a simple one because it only took 1 step. So some problems are going to take more than 1 step, so let's try some of those. So question number 2, how many inches are in 3.78 meters? So we're going to do the 6 steps again. Step 1, what are we trying to find? So let's read this. How many is the key phrase. Notice last time it said calculate was the phrase. This time it says how many, but then we have inches. So I'm looking for equals inches. So that's step 1. We're done with that. Most people find that an easy step. Step 2, what are you given? So what information does the problem give us? So it gives us that there's 3.78 meters. 3.78 meters. And we're going to make this in a fraction because it wasn't already in a fraction. So I'm going to just put that over the number 1. So I remember the meters is on the top. Technically, inches is also on the top of a fraction, so it should be on the top also. Step 3. Is there any other information that we need? Because we're kind of stuck. That's all we were given in the problem. So yes, I need more information. Either I know it off the top of my head, or I can look it up and I'm looking for things that are equal to each other. Well, I go back to my handy chart up here, and I'm going to look for things that involve meters and inches. I know I'm going to have to get rid of meters, so let's look at what we have about meters. Now we got some problems this time because I have more than one thing that involves meters. I have that there's 100 centimeters equals 1 meter, and I also have that there's 1,000 meters in a kilometer. So which one am I going to have to use? Well, you might want to think ahead to see what will help you solve the problem. We're going to end up with inches. Well, I also know about inches, that there's 2.54 centimeters in 1 inch. So if I use this fraction, it will help me eventually get to meters. So sometimes it's good to think ahead where you're going to be going when you do your problem. So let's go back to here. And now we're ready to do step 4. So we're going to set it up so that the unwanted units cancel and we end with the desired units. So we're going to do 1 unit at a time. So the first unit that's undesired is meters, and we're going to end up with inches. So I need to have a fraction that involves meters, and so we decided this would be more helpful than this. So meters has to go on the bottom. So I have 1 meter, and then I have 100 centimeters. So that's going to go on the top. Meters cancel. And I have currently centimeters, so I want to do a check. Centimeters is not where I'm going, so I'm not done with my problem yet. So I got rid of meters, but now I have some more unwanted units. So now I got to get rid of centimeters. So I go back to my fractions up here, or my equivalencies that I'm going to turn into fractions, and I see that there's 2.54 centimeters in 1 inch. So which goes on the top and which goes on the bottom? Well, I need to get rid of centimeters, so that's going to go on the bottom. And inches is going to go on the top. Centimeters cancel, and I'm left with inches, which is what I want. So I'm ready for step 5, which is to solve. So now I'm going to take out my calculator, and I'm going to plug in 3.78 times 100 divided by 2.54. Notice I skipped all the ones. Why? Because if you divide by 1 or multiply 1, it doesn't change the answer. So I just go 3.78 times 100 divided by 2.54. And what does that get you? Well, on the calculator, it gets you a longer number again, 148.819. Okay, so it gives you a long number. That's too many digits, so I have to round this. And I round using significant figures. So I have 3 significant figures here. This doesn't count because it's a definition. And 3 significant figures here. I can only have 3 in my answer. So I can't just get rid of this 819 because this is more than halfway. So I have to round up this time, and that makes 149 inches. So now I've solved question number 2. And let's just do one more for practice, and hopefully you've got the hang of it. And here we go with our third and final one for today. What is the volume in liters of 67.9? Oops! There, see, I told you I forget step 6, and I just did. So let's go back. Let's try step 6. Check your answer. Do the units cancel? Did you get the right units in the right place? Does the number make sense? So let's check that out. So don't do what I just did. You got to check your answer. Meters cancel, centimeters cancel. I get inches. That's good. I have inches on the top. I have inches on the top, so it's in the right place. Does the number make sense? 3.78 meters. Meters are pretty big, and inches are pretty small. So I probably end up with more inches than I have meters. So yes, I had a bigger answer. So the number does make sense. So great, we did step 6. So now let's go to our final question and solve that one. So let's do all 6 steps this time. What are we trying to find? What are the units in the answer? So I read this, and it says, what is the volume? Volume is not a unit, but it tells me what units. So what is the volume in liters? Now notice this time it says, what is, how many, calculate the. These are all phrases that tell you what you're going to find. So what is the volume in liters? So I'm going to once again put equals liters on the right-hand side so I know where I'm going. Step 2, what are you given? And put it in fraction form. So I'm given 67.9 kilograms of aluminum. Notice it tells me now what material I have. That may be important, so I'm going to keep that information. So 67.9 kilograms of aluminum, and I'm going to put that over the number 1 to make it a fraction. All right, so that's step 2. This is where we're going. This is where we're starting. Now I've got to plug in the middle. So step 3 is there any other information you know or can look up that will be helpful? And we're going to put the equivalencies in fraction form. So this time I'm looking for something with kilograms of aluminum, and I'm going to liters. So let's go at the top. What do I know about kilograms? Kilograms. So here I have information about kilograms. I know there's 1,000 grams in 1 kilogram. So let's move that over so you can see it. Now it doesn't say aluminum, so I have to think for a minute. Are 1,000 grams of aluminum equal to 1 kilogram of aluminum? Yes, it's 1,000 grams of anything equals 1 kilogram of the same thing. So I can use that, okay? What else am I going to be able to use? I need to get to liters. Well, I also know that there are 2.70 grams of aluminum equals 1 milliliter of aluminum. That happens to be the density of aluminum. All right, so that I can use. And then I'm also going to use something with liters in it. Well, there are 1,000 milliliters in 1 liter, so I'm going to have to use lots of fractions. And sometimes it's easier to use the fractions as you go along. So you can plan it out in advance, which is a good idea, or you kind of do it as you go along. Both work out. All right, so 67.9 kilograms of aluminum. I have to get rid of the kilograms, and I have to get to liters. Huh? So I go back to what I learned about kilograms. There are 1,000 grams in 1 kilogram. So what goes on the top and what goes on the bottom? I'll give you a second, see if you can figure that out. 1 kilogram goes on the bottom, and that's of aluminum. And there are 1,000 grams of aluminum for every 1 kilogram of aluminum. And notice I got rid of kilograms of aluminum, and I'm at grams of aluminum now, but that's not where I want my answer to be. I want it to be in liters. So I keep going. So what do I know about grams of aluminum? Well, the density of aluminum. I know there's 2.70 grams of aluminum for every 1 milliliter of aluminum. So once again, use a fraction. What goes on the top or the bottom? Well, if I've got to get rid of grams, it's got to go on the bottom. So I have 2.70 grams for every 1 milliliter of aluminum. And that should be not capitalized. So grams of aluminum cancel. And now I'm at milliliters of aluminum. Well, I wanted liters. Okay? I'm at milliliters. So what's my next step? I gotta get rid of milliliters and hopefully get to liters. So what do I know? And this one you should probably know without looking it up, but here it is. There are 1,000 milliliters in 1 liter. So we go back to our problem down here. There are 1,000 milliliters in 1 liter. Okay? And the milliliters cancel, and I have liters, so I've done step 4, which is get rid of everything unwanted, and I finally got to liters, which is what I do want. So now I can go on to step 5, which is to solve. And I put this in my calculator. I have 67.9, forget the 1, times 1,000, divided by 2.70, divided by 1,000. And I get, once again, a longer number than I need. This is the unrounded number, something like 25.148. But I have to round that to significant figures, so I have 3 here. This doesn't count because that's a definition. 3 here, that's a measured number. This doesn't count, that's a definition. So 3 significant figures, so 25.1. This is under half, so I can get rid of it. So 25.1 liters, all right? And then let's not forget step 6, which I almost did last time. Let's check our answer. Do the units cancel? Did you get the right units in the right place? Does the number make sense? So units cancel, kilograms cancel, grams cancel, milliliters cancel. I get liters in the top. Liters is in the top here. Does the number make sense? Well, this one maybe not as easy to figure out, but it does make sense. 25.1 liters, and that's our answer. So hopefully this helps you remember how to do unit analysis problems, and you can try solving them all on your own. Thanks for listening.